Okay, I think we'll start and maybe some people will join later. So welcome everyone to another session for NFL Armenia. Today we are joined by Avetik Kalantaryan, who's the Director of Representation of Schneider Electric in Armenia. Avetik has worked with a lot of different stakeholders regarding such topics as energy efficiency, energy management systems. He has worked with different players on the market, with universities, with hotels. But today we will focus specifically on the energy management systems for buildings and what are the issues in Armenia and what are some solutions that have been implemented or are advisable to implement in the future. So we'll have a presentation for about 20 to 25 minutes, followed by Q&A. Please keep your microphones muted during the presentation, and it will be recorded as always and put on YouTube. So Avetik, I pass the floor to you.
I thank you, Armin. I cordially greet everybody at this meeting and express my gratitude to the national future energy leaders. And this is a good challenge and a very good initiative. And I readily give my consent to join your activities and contribute as much as I can by virtue of my work in the country, and by virtue of just knowing Armin Danielian and his efforts, which had begun several years ago when I first time met him when he was still a student in a British university, and we were eagerly waiting for such specialists to return back to the homeland and bring with him new knowledge, new mentality, new technologies, new way of thinking, and distribute that vastly in the society and gather around himself professionals like you. I just want to pay my compliment to all of you. So today we're going to speak about the energy management system and how they are applied in Armenia and to what extent they are applied in Armenia. And I would also focus on what should be done, what is advisable to be done in order to bring the Armenian electric energy network management to a modern level, to the level of the 21st century, where we live now. A little bit about myself. I have been working for several international companies, 8 years for French Alcatel in telecommunication sectors as the country senior officer. I started my employment as a government employee at the diplomatic service in the Ministry of Foreign Affairs years ago, shifted to Ministry of Finance and Economy, worked on projects of World Bank and the government in implementing monitoring and management of foreign aid coordination in Armenia at the very difficult times when Armenia just became an independent state and acceded to the United Nations family. After that, I moved to Alcatel, as I said, and had also opportunity to work with a couple of United States-based companies in the IT sector. And the recent 5 years, I was invited by, again, French investor, Schneider Electric Group, to lead the representation of Armenia, of this international vendor and manufacturer in the Armenian market. It was, and it is, a success story. We are happy with the results and are following the ongoing activities in the world, which hinder our activities, unfortunately, starting with pandemic 2 years ago, and now aggravated by the war conflict between Russia and Ukraine. And these were the territories through which all the logistic schemes were bringing our equipment to Armenia. They are now destroyed, and we are now re-establishing new supply chains, new value chains to bring the equipment in Armenia. We succeeded in it, so we are full of energy and full of hope that everything will be all right. Now, let me introduce to you my thoughts, my vision from the point of view of my employment and knowledge and contacts in Armenia with practically all players in the energy generation, energy transmission, energy distribution systems. If you paid attention, I just enumerated for you the full structure of the Armenian energy system. Our agenda today, I want to propose you some topics in 5 sections, starting with what is power grid and how the failures are happening and what response should be brought to the failures, connected devices, and the rest, which are integral part of a concept which has been developed by Schneider Electric, my mother company, and by application of which we have introduced into the market reliable, efficient systems and solutions for effectively managing the energy distribution networks. And I will go on in different layers of this concept of eco-structure, explaining why it is important, what benefit it gives to the operators, and at the final end, it yields a result which we expect to be able to manage in a clever, smart way and bring the network to a situation when it is a manageable infrastructure, managed not just standing in the field face to face to the outdated energy equipment, but manage the network sitting at the table and playing at the desktop. What is the energy network, energy distribution network? You see here only the distribution part. On the left side of your screen, it is the generation part, which are the nuclear power stations, hydropower stations, thermal power stations, whatever, solar power stations, wind power stations, alternative energy, geothermal energy generators, which give the energy to the transmission network, the high voltage transmission network, and after which the energy passes to this network, the picture of which you see on the screen. It's the distribution network, which has twofold structure: the primary distribution network and secondary distribution networks, at the end of which is the plug where we plug in our socket for our PC or the mobile phone. And we as Schneider Electric provide and supply and manufacture energy systems and equipment practically for all the layers which are introduced on this slide. Every network, any network in any country at any level of development, any level of management, any level of equipment at top level or the outdated level has the right, it has give the right to the equipment that it can be broken. It can make faults. It can produce damage. It can produce failures, which is the basic headache of any energy distribution or energy operator. It's a headache because they provide this service. They sell this electricity to their customers, to their subscribers, to us, to the population. If it happens, so the information goes to the press, to the mass media, and they start to reprimand this network operator, claiming on the bad quality of the network, bad quality or low level of service provision to the subscribers. Let us pay attention to the financial impact, what may happen in the failures. For example, we have taken information from the US sources. For 1 hour failure, you see how much loss in euros it can produce for different organizations, different sector companies, for health system, for stock markets, for banks and credit organizations, for utility services. And that means that operators start losing money, huge money. If you see the number of zeros after the figures, you will understand how much loss can produce just 1 hour of energy outage. That is why it is very important to have in place manageable, high quality, efficient, operational network of energy distribution. If we take some statistics from the world data, and the sources are indicated under the pictures, 59% of all total interruptions in businesses is due to fire, explosions, damages like this in the networks. The first cause of fire in industrial enterprises is electrical equipment failure, which makes the 22% of all fires. When we see in the newsreels, news information channels, that there is a fire somewhere, it happens very frequently. So 22%, even more, are a result of bad electrical equipment switching systems. And 56% of all electrical fires are due to lack of proper maintenance, which means that maintenance teams were not available on site to take care, which means that behind that, there are no signals coming to the management, to the network management centers, to the dispatch centers, for them to be able to send the information to the outage management teams, for them to be able to very quickly move to the site and take care of the situation. And all this chain should be properly managed in modern networks. So the damage for fires, bad quality, but lack of maintenance, lack of service personnel is a very dangerous factor for networks to be to face and encounter situations of failure. And causes of equipment failure are different according to connected to different situations. For example, faulty connections. It makes 25% of the cases when failure occurs. They are caused by bad connections, loose connections, or contaminated surfaces on the contacts of equipment. Or in harsh environmental impact, 20% of failure is caused by condensation and pollution of air, dust, dirt, and temperature differences in the equipment room when they are, or under the open air when they are located. And circuit breaker health is the most important factor for proper operation. Bad situation is caused by, and fault is caused by, operating mechanism excessive contact wear and low voltage auxiliary failure. If we diagnose all the cases of failure, so this is the statistics which comes from the world operators to analytical agencies who provide this data to us to understand how we manufacturers and providers of service and solutions should act, react, and introduce these ideas into the manufacturing process in our plants. Let's move to the concept of which I was talking. This next section will be dedicated to the connected devices, connected equipment. Let me first demonstrate to you this EcoStructure exceptional model, exceptional structure, exceptional concept, which was introduced to the world market by Schneider Electric. Whatever Schneider Electric produces, they are based on this concept of understanding that all the devices should be able to operate, to work, and provide service within this structure. It is three-layer structure, as you see. The lowest layer, we call it the first layer, is called the connected products, not connected devices, which means that any piece of equipment, critical power equipment, even non-critical equipment in the network, which is connected into the energy distribution network, should be somehow connected to your centralized system of management and transmit data from where they are installed. Equipment rooms, substations, low voltage substations, distribution substations, remote subscriber units, wherever they are, in the generation plant, in the transmission highways, they should be connected somehow and transmit the data which they generate. When they transmit the data, it should go to a second level, which we call edge control, the medium level. Edge control is the layer where the transmitted data from the first level are collected, aggregated, and software solutions, software product start monitoring this to understand where this data is coming from, where this information is coming from, what is the situation, what is happening. If it is a one small network, closed type network, it's easy to immediately locate the place where the failure is coming or fault has happened or alarm signal is moving there. If it is a large network, city network, regional network, country network, you can imagine how difficult it would be to allocate the place, the location where it comes through to the management screens for engineers and dispatch service to understand what should be done and to react and to send brigades of outage management there to take care. And on the top is the third layer, which we call applications, analytics, services. This is again a software solution center, which is a center which is thinking like a human being. We have done our best to create software which thinks and monitors as we human beings will do, but in a very quick way, in a very intelligent way. They analyze the situation, they give advice what to do, they prompt steps and measures to be undertaken to the dispatch engineers, to the outage teams, to the senior managers who should make decisive decisions and send the resource, human resource, engineering resource, or technical resource to the site, to the location, to take care and correct the situation, to apply corrective, predictive measures to restore the network operation. So please hold in your mind, keep in your mind this eco structure, because the rest of our presentation will be clear description to you of every layer, why we consider it very important in the energy management networks. If we have established such a concept, such a layer, such a structure at the core of the networks, we can sleep at our home without problem. The engineers, senior responsible personnel of any distribution network may be sure that every operation, every minute, every hour of operation is under control. And if at this situation something happens, they can be sure that the situation is manageable. Their corrective action is there, arranged, planned, organized in time. So let's go further. As I said, collection of information and data from the devices which are in the network in the substations is very important. On this slide, you will see on the right side the optional sensors. Small sensors, we call them small insects because they are not more than, they are even smaller than a matchbox, very small. They are 15 years of battery inside, wireless, but we have also wired solutions of such tags. We call them power tags, which are just glued to the equipment or bandaged to the equipment or just put on magnetic level on the equipment, and they start transmitting information from these devices. The information will maybe different. It might be temperature, it might be electromagnetic field, it might be radio frequency, it might be something. They just transmit this information from the connected devices, and you see medium voltage equipment in the center, and with these points in different colors, we just indicate what device from what place, what kind of information is transmitting from the device they are connected to. ESRG, CEPAM, for protection relay, IEDs, sensors. All this information is coming to the monitoring second level on the computer screens. They are validated in the architecture. The engineering specialists and dispatch engineers see them, locate them, immediately find the place where they are attached to in the network, and report a situation. Have a look at this. Do you see my mouse moving on the screen?
Yes, we can see it.
So I demonstrate to you the power tags. 1, 2, 3. So on every connection bar, every connection cable, if you want, connection point, it is just bandaged with a band, and that's all. There is no need to screw it, to glue it, to fix it. It is fixed with a band, and from that second it starts transmitting data. The protocol for transmission are different. It's industrial protocols, but it can use also the Wi-Fi. It can use the Modbus. It can use the mobile wireless protocols like Zigbee, others. They support very many industrial standardized protocols for transmitting data. We consider very important that, look, we are looking at a bus bar connection to the medium voltage equipment set, and from every bus bar polarized, they are transmitting the data 24 hours, 7 days, every second to the engineering dispatch center for engineers to understand what is the current situation, what is going on inside this one equipment. But imagine how much equipment are installed in a variety, thousands of substations. Another example, see, the bus bars themselves, they may be of copper, they may be of aluminum, there's no difference, but the power tags and the transmitting equipment can be simply just attached very seamlessly, easily, without switching off even this equipment to the equipment. And from that point of connection, they start transmitting the data. The connected device starts working and providing. It starts speaking to the engineers. It starts speaking and communicating with humans. Even the cables, not only the bus bars, but even the cables. All configurations of power tags are available. As I said, wired, wireless, they may be coupled with meters, coupled with other connectors. Another example, see, it's just a small insect. It is just put on the bus bar. They can also be placed with cable connection. There are options with cable connection as well. Have a look at the transformers. Transformers may be dry and maybe oil transformers with a tank on top. Here you see dry transformers, which are more secure in operation, more secure from the point of view of fire protection and fire risks. Even on these transformers, on the left side, you see power tags at every bus bar. Power tags at every bus bar on every coil. From the front side, from the back side, it's possible to even put tags on the connection rods. These are the rods for seismic protection of the power generators, because they are very heavy, and if you have paid attention, they must be placed on wheels, because during a seismic shock they must have a possibility of moving in order not to be exploded or broken. Another option is oil transformer. You see there are oil tanks on top. Again, even in such solution, power tags are available to connect them to the network management center. or power tags which can go inside the equipment, at remote places, at non-visible places. There is no need to look at them. The engineer or the electrician who is checking the situation does not need to view, to visualize them, because the information transmitted by them goes to the computers of the network engineering dispatch center. Very many benefits of safety, very many benefits of protection of humans against electrical shock, and again, even protection against animals which may happen in the substations. I don't want that my words seem strange to you. In the Armenian substations, I have seen families of hedgehogs, snakes, frogs, rats, whatever, dogs, cats, who are living inside, because there are very many holes, badly constructed, badly managed buildings, lot of dirt and garbage inside. We have seen everything. And even we have to be careful that even these animals are not damaged, except people. Another example, Isergy is one of the most popular power tags we use. And it goes even not only to the wall of the equipment, but on the installed equipment on the wall, for thermo relay, temperature relay, whatever. It goes on because the network engineers consider that information from this specific device, this one single device, is important for their decision-making processes. Another primary range power distribution, medium voltage power distribution cell. You see, again, we can place the power tags, connect the devices on the most critical parts inside and on the bus bars and the compartments of the distribution cell. We can pair it, we can couple it, we can double it. Every possibility is available. Inside the drawer, outside on the face plate, wherever we think possible, the connected devices. So we completed also the second section about the connected devices. Imagine, with all of you, we have now spent some weeks in working all the substations and have distributed all these power tags, connected devices, meters, sensors in all the substations, and are running back to our offices to see what information is coming to the monitors of our PCs. And that we are moving from the connection for the lowest layer of management of the EcoStruxure concept to the second medium level, which is edge control. We call it system monitoring level, where the data is coming and the engineers starting to monitor the situation, aggregation of data, standardization of data, moving them into different layers, different drawers, starting working with this data to monitor them. What is power management? Let us just once again remember that power system and its management are critical process. It is really very critical. Why electricity? While power is critical in the life of a human being. Because everything depends on power. Our television, our radio, our refrigerator, our mobile phone, our lamp, everything depends on electricity. If we have electricity, we have internet, we have Wi-Fi, we have everything if we have electricity. When we don't have electricity, we are becoming I don't know what we are becoming, a person deprived of everything available in this life. We are becoming a man at the age of the historical time when a monkey stood on his 2 feet, on his back 2 feet. We are moving the mankind to the prehistoric time, pre-human time. We have electricity, we have everything. That is why it is considered to be in all of the the world, in the human philosophy, a critical process. Processes in our facility, in our distribution networks, they need to be monitored and managed. If we keep it like it is, it will explode, it will produce faults, it will produce damage, it may kill a person, take that God away from everybody. Electricity can kill a person or animals. Power management is an ongoing measurement of the electrical power distribution system by means of smart, intelligent, communicating energy and power devices connected on the devices, communicating to the software for collecting all the data there, for the need of visualizing them, analyzing them, reporting them, and taking care of the consequences which this information bring to the energy companies. On the lowest side, the lowest part of this slide, you see the pictures of different software solutions, software products which Schneider Electric produces for energy distribution operators. Every manufacturer, provider of electrical equipment in the world, whatever name it is, whatever country it works for, they have similar systems. They produce similar systems. Otherwise, the equipment which they sell in the market will not be purchased by anyone, because if they are not managed, nobody needs such equipment. So modern equipment should be managed, which means our monitoring software for different situations, for different applications, for different needs and preferences of the network operators should be in hand, should be available in the network operator offices. This is question number one. Is it the situation with Armenia? I am not sure that I can respond positively. I am not sure. My experience, my visit, my knowledge, my personal information from network operators, I respect them very much. I am inclined and dedicated to support them. I use much of my working time in the offices of the operators than in my apartment. Not all of them, the majority of them do not have such software system. They have something, homemade software, third-party software, something they may have, but not the whole range which is needed for a modern operator. Pay attention to this software. I'm going to introduce them to you one by one in very short introduction. Again, infographics. In the new world, in our world, we need more electricity, which means that 2 times faster growth of electricity demand in our societies compared to the energy demand which we have. In 2040, it will be doubled. In 2025, we will have more digitized connections, connected devices. The amount of increasing, the amount of growth will be more than 10 times connected devices. The decarbonized world, the United Nations today is just waving a flag and is announcing an alarm that the climate is being carbonized, climate is being damaged, and the countries and enterprises have to take care. So 82% of the untapped energy efficiency potential in buildings, this is the buildings where we live, are producing more than 50% of this carbonized dirt into the atmosphere, and more than 70% decentralized new capacity additions will be renewable starting from 2040. Before 2040, all the stations should be installed as much as possible to replace the energy generation based on coal, or based on oil, based on gas, and to replace by alternative renewable energies in order to reach 70% of decentralized decarbonized world. On the top side, you see the traditional power distribution model, generation, transmission, distribution, and we as customer at home or in the office. The new model, today's up to contemporary network model is different now, from generation to transmission, and here the story begins. We send to the network, distribution network, which today is moving from a traditional network distribution model to smart grid, smart network model. And here again, instead of one type of energy generation, we are having more operators who are generating energy on renewable energy sources, like accumulation sites, solar energy, wind power generation. They are also working as smart grid and are providing energy to the population. Where we are on the right side, demand response. It is the community which pays for this generated and distributed energy. And at the end, our wish is to have efficiency of this energy use. Complexity. This new model of energy distribution network, introduction of smart networks, alternative and renewable energy sources brings challenges, and these challenges should be managed. I don't want to dwell upon too many figures, but without this answering and addressing this challenge, we will not be able to manage the new era of power distribution and network management systems. For example, there is an average 10% potential reduction in energy cost in critical facilities, and an additional 15% savings in maintenance of operational expenses. Every topic which is brought here is very critically important. If we don't take care of these challenges and bring response, which means we lose money, we throw money outside the window, and the network operator goes to losses. Monitoring level means monitoring the power. We have a very good software product which is called Power Monitoring Expert. For application in Armenia, dear Armenian colleagues, I will be happy to invite you very soon when we have started a project in introducing Power Monitoring Expert monitoring software in the National Polytechnic University, and we are trying to install in the first international hotel in Armenia. And just as a trial, free of charge, it's not a commercial project, just to show to the management and to show to the users how effective it is, how much yield and benefits they will yield by means of using this software. Let me not dwell upon too much, because I want to introduce this, demonstrate this system to you when it is connected in the facility, and we will have the opportunity to play on it to see how much benefit it brings to the user, to the owner of the buildings. We want to connect in the National Polytechnic University up to 5 buildings in one network and manage from one room. The architecture of that Power Monitoring Expert is like this. See how many devices should be addressed, how many power tags and connection points should be addressed, how many equipment should be connected to transmit the information on the upper level, the monitoring level. And this information by different user interface visualization will have to be managed by the owners of the facility. Why it is important to have the monitoring software, different ones? Because first of all, we fulfill the international standards organization requirements. The world lives on standards. Equipment are produced, manufactured based on standards. If they are not giving response to standards, to demands, to the requirements, if they are not compliant to the standards, they will not be, nobody will be able to sell them in the market. And licensed operator will not have even the legal right to purchase equipment which are non-standardized. And the challenges in the standards are very well depicted on the left row of the column, and see how much simplicity and complexity they bring with themselves, what type of solution, what type of benefit the power monitoring expert brings to the facility managers, facility owners who apply and install such monitoring systems. I'm talking about the simplest system. There are more complex ones, for more extended ones, for large operators, of course. What do they monitor? The windings of the power generator. They may be, I'm sorry, transformer, power transformer. They may be oil transformer, or they may be dry transformer, whatever. There are coils and windings inside, which transform the energy. And we start monitoring from the coils, from the windings, which gives us possibility to maximize the safety, maximize the capacity of the transformers. Medium level, medium voltage distribution cells. You have seen this picture. I want just to once again to remind that the power tag goes inside to the critical place from where the information is gathered, and it is important, critical information for the monitors. At the advanced levels, even on the arc flash solutions, we take care to have the information 24 hours, 7 days, round the clock, in order to be able to be sure that all the information is available for our decision making. The software of power monitoring expert or other software which is used for monitoring, they can be off-grid, installed in a server of the enterprise. They can be in a smartphone for remote operation. They can be in a SCADA system or human machine interface system, or they can be in a cloud if the operator agrees to transmit the data to a cloud, which is provided either by network operators or by manufacturers like we are. If they agree, so they have the possibility to collect and analyze the data in every device, in a mobile equipment, in desktop equipment, in a structured system, or in a cloud. An example of having a system, monitoring system, installed as a mobile application in a smartphone, which can count on information and monitor the information of the equipment installed in the building, and the monitoring expert, monitoring engineer or dispatch engineer can visualize that, even not being in the room in front of the equipment. Or metering equipment, reading of the meters on circuit breakers, on different parts, to receive notification on alarm, on pre-alarm, or receive information from the cloud, even on the mobile device. Everything is available, possible, and these modern applications, cellular applications, mobile applications, are at the service of energy network operators by manufacturers like we are. See the architectures on the medium voltage substations, the architecture from one metering device, how it is connected to the pool, to the programmable logic controller, to the human machine interface, to the concentrator, to the GSM modem, which gives the opportunity for different types of users in the enterprise on the site to use this data, to visualize this data. Is this available in our network operators? Again, I fear to say yes. I fear to say something positive. I have not seen them. However, there are very good examples, local examples, localized examples on one substations, on two substations, but the countrywide network is comprised of more than 2,000 substations. Imagine how much investment should be needed to have the network in a situation of smart grid, smart network. Let's go on. Pressure, to monitor the pressure, air pressure, gas pressure, whatever, in the insulation tubes. To monitor the even the aging of the equipment. Is there any rust there? Is it outdated? There is a time to remove, to replace, to update, to upgrade. Even these tags give information from the automatic switching equipment, automatic switching centers, that their age is coming close to be replaced, to be removed, and replaced by an analog, or replaced by a more advanced machine instead of the old outdated one. This software also gives the possibility, the monitoring software, to have all the log information inside the software. Every piece of equipment which you have in the network, what kind of tags are available for them, what kind of tags are connected to them. Is it compliant to this tag or not tag? What is, and this picture, this roster, this situational map chart shows to the engineer the full situation of network data collection, data aggregation in the monitoring software. This is the same file which I showed to you at the beginning, which is the EcoStructure concept on constructing the network. The layer of connected devices, the medium level is the edge control, and the top level is the analytics. Simply, it is, I prepared this just for visualization of how many tags, how many equipment, and on what type of equipment can go. They come to what type of software, and they go up to what type of analytical and services software. To make haste, we are coming to the fourth upper level of applications, analytics and services of EcoStructure. Again, on the lower side, lower layer of the slide, you see the pictures of the products of software, which are very clever, very smart. They are created specifically as helpful instrumentation, helping hand and advisors to the network dispatch engineers. They speak, they show, they demonstrate, they provide solutions, they provide options, they offer steps, they offer scenarios, and they give tools for modeling of scenarios before going to use it. Very clever software, very complicated software, sophisticated one. And one of this software, we will dwell upon it more. Armin, I have bypassed my time.
Well, if you want to quickly go over the remaining slides.
Yes. So one of the software is ADMS, Advanced Distribution Management Software. Another one of such software, analytical software, is an Asset Advisor, Microgrid Advisor, Power Advisor. There is even a video film here. Let me skip that. I wanted to show a 60-second video to you, but the voice signal is not coming to your rooms. We checked it. I listened to it, but you don't listen to it, unfortunately. IT Advisor. There is also a software for IT equipment, because in such clever networks, in such smart networks, you cannot do without using IT equipment. IT routers. Routers is not to be able to transmit information from your equipment rooms to the office of the general manager, for example, of regional manager. Based on such software, based on such analysis, which you get from the software, or even mobile applications like augmented operators. There are tags and signs on the codes on the equipment, which you can read by using augmented reality software with the gadgets, and see the situation, read the documentation, not carry them with you, but have it in the cloud. Based on all this information, the distribution companies are generating their service plans, consultancy plans for their engineers and brigades of maintenance. They formulate their support. their monitoring, their advice, their analysis, consultancy, everything. They prepare their service portfolio based on all this software. And service portfolio is their response, quick response to the situation and quick response to the demands of their subscribers who pay for their services and purchase the electricity volumes. And the last part is about managing the networks, about smart systems of managing smart grids, distribution networks, advanced distribution management systems for energy networks, digitization of the information, and creating digital twins of the networks, network maps, diagrams. Look, what is our solution? What is our proposal? Proposal is the following: to create software. We call it SCADA, electronic SCADA. We call it Advanced Distribution Management System. Whatever, they may have different names. Many manufacturers have such software. Simply, I am proud introducing this because on the Gartner group and Magic Quadrant analysis, Schneider Electric is on the top right side. And below us are very, very small number of companies. It is the seventh year in a row, Schneider Electric proves its world leadership in such systems and solutions, software systems and solutions for managing networks. ADMS combines different components of information, data gathered into one unique standardized network, like geographical information system, electrical supervisory control data acquisition, SCADA system, or distribution management center, or distribution network applications, outage management system, etc., etc., etc. It combines very many applications, very many information and subsystems into one software, creating a database, creating a wealth of data for energy network managers and dispatch centers. In fact, after applying such systems, there is no need to keep in the distribution centers professional network dispatch engineers. They can be replaced by simple operators, computer operators. I am talking about dangerous thing for the Armenian network managers, but when we tell this is how can we take the risk that a computer operator, a young lady can sit in front of my network management center? Incredible, impossible. Gentlemen, it is possible. It is happening in more than several thousand operator networks in the world. Armenia is not an exception in the world with the current situation, and we advise such systems to be applied. Fortunately for us, we have opened very serious professional discussion with the network operator in Armenia, and it is on the table of decision now. What benefits they can get? A variety, a wealth of benefits by means of using and applying this software. It's a matter of management decision to go for such a solution and to train own personnel for introduction of such smart system and to make their network from a collection of outdated, non-manageable equipment to smart, clever networks. The building blocks of such advanced network management system may be these 6 blocks which I introduced. They may include even 12. They may include even 20. There is a variety of blocks we can offer. It depends upon the choice of the operator and upon the configuration and the scheme and applications of the networks they have, and the level of equipment and technology they use in the networks. Outage management center. This is the most painful question for every network operator. When failure happens, the symphony begins. All the instruments in the orchestra start to make noise, to play a music, and the conductor cannot manage such an orchestra. Impossible, because there is no system of management. They don't know where is the place of the damage, what has been damaged, how severe, to what extent severity is the damage happened. Is there fire or not? Anybody killed there or not? Any explosion, is it an area of residential dwelling or is it an industrial area? They have to locate the place. How much task force is needed to reach there? How many vehicles, cars are needed to go there? How much petrol should be in the tanks? Do they have communication to talk with us from the point where the outage has happened to our managers? How much time it may take until they repair the situation, etc., etc. Loss of resources, loss of time, abuse of human resource, abuse of instrumentation, analytical information, vehicles, petrol, gas, etc. So outage management system is very well managed in the software. Everything is connected into the network. If you see the screen on the right side, outage prediction and analysis, this software gives you the map, which is overlaying on the network diagram, one line diagram, and it is coupled with geographical information system. You can see from the satellite where the place is, zoom to the place, find the place, and send your people to make the management there and get communication from them on online regime. Even this system gives you possibility to predict storm, wind, rain, tornado, whatever, which may happen and produce demand. Moreover, we give communication devices to the engineers on the site who are working with the failure to be able to report the situation, give us online quick information for us to be able to reconnect the disconnected subscriber and continue getting money for that. The architecture of such clever system, ADMS or SCADA system, may be like this structure. Different manufacturers may have different structures, but it is the building blocks, the architecture of the core of the system. It's the distribution management center, outage management center, SCADA for collecting the data, visual possibility, visual and reporting, mobile communication, and management of the workforce who is on the site for repairing the situation. The most important part of this software, analytical software, is to try to transform a paperwork, the one-line diagram, which sometimes is not of this quality. It is of on a school copybook with pens and fountain pens made very beautiful in brackets design, and it is the network diagram which is used by the company. We have to make a digital twin, digitize that map, a digital twin, and this digital twin should go into the software, into the screen. See how we transform the images, maps, videos, drawings, diagrams into digital material, which are already possible to install in the data center, in the data, and to be used on the screens and give information and to be used by engineers. This is the last slide. That's the general architecture of a SCADA system, where the connected devices on the left side, field devices, connected ones, who aggregate the data to the monitoring layer. The monitoring layer also, if it's a very, very well managed, they send it to the enterprise server, either offline or in the cloud, and make also an archiving of the data in order to be able to see for the log files, going back retrospectively to understand what was the situation 2 months ago at this specific date in this area at 3 o'clock in the morning, to be able to find the information. And they are demonstrated on the monitoring and services analytics software interfaces for users to be able to use. I thank you, and I'm ready to respond to your question. make my excuses for speaking too much. The information simply, I would want it so much cordially to transmit all the information to you. I thank you.
Thank you, Atik, for your presentation. Again, it was very passionate, and we can see that there's a lot that you know and you wanted to pass on. So in terms of questions, we have a couple of questions that were submitted through the registration forms, and people who are now in the chat, if you have any questions, you can raise your hand and we'll come to you shortly. So one question that was submitted earlier was from Tigran Sekoyan, and he was asking if you are familiar with the work done by UNDP for MEMS, which I presume is energy management systems in Armenia. Do you know any work that UNDP has done?
Very poor information. I have had no chance to be on the site to see. Simply, nobody invited me on the inauguration for me to be able to see. No. Okay. If they invite, I will be ready to visit.
And another question from Hermine Sanvelian, and she was asking, from your experience, does energy efficiency matter to real estate market?
Real estate, only in terms of energy usage. If real estate market, which mean, do they mean the residential market? Is it the question about the residential market? Because real estate market, I understand selling of real estate, apartments, land.
Yes. Let's assume that they mean residential market. Yes.
Residential market is one of the greater part of consumption of energy in any society. As you see in my slides, there was that more than 40% of pollution into the air is produced by residential buildings. We living in multi-apartment houses, buildings, and in private houses, in summer houses, we produce too much gas, too much smoke, too much noise, too much electricity. We abuse electricity, etc. We produce very much damage to the environment, and they are considered to be the largest consumer of electricity in any society in the world.
If I could reformulate, I guess, the question a bit, maybe what the questioner was asking is, from your experience, at least when people sell or buy on the real estate market, do they care about the energy efficiency of the building or of the apartment, or?
Very low, very small amount of people take care of that. I have seen many apartments now, multi-story buildings with many apartments inside, where we have solar panels on the rooftop. We have even water heating on solar energy. I have one on my rooftop. I'm in the third floor of a multi-apartment building. I have seen many, but they are not the majority in the society. So, which means they don't take care.
We have a question from Hasmik Barsahian. If Hasmik, if you want to ask, or I can read the question. Maybe she's busy. I'll read the question that she was asking. So what are the challenges that the Armenian power system is facing and will face in the upcoming years, specifically related to the rising share of renewables and to the new market liberalization policy?
Very good question, but it is impossible just to answer in 2 minutes. It's a very large question. It's several questions in one, combined in one. I'm happy that in Armenia, it is already the reality. We are living in a situation of demonopolized energy distribution market. And by the help of a talented IT company, Synergy Systems, new power electricity distribution exchange has been created, and they manage that exchange. It is a software system created by Synergy Systems in Armenia, and it made possible, it enabled to connect to that exchange, power distribution exchange. More than 6 companies now, if my memory does not fail, are connected to that exchange. In addition to now traditional national monopolist, Armenian electrical networks of Armenia. They are solar power generator companies and other and hydropower generation companies. With the course of time, many other power generating companies, renewable energy generators, on wind power, on solar power, on hydropower, or maybe also on geothermal power generation, will be connected to this exchange. Now this exchange is working with 6 participants there, and they are selling electricity only to the industrial customers. If my memory does not fail, starting with 2025, we usual citizens also will be connected to this exchange, and we will be free to buy electricity from any operator at the tariffs which they propose to us, which means we are at the beginning, fortunate case for Armenia, at the beginning of the monopolized energy distribution market, where I am also answering to the next question, where there are also alternative and renewable energy generation companies connected to the exchange. If I missed anything, please remind me.
I think we could maybe the last question to follow up with that one regarding market liberalization. So Armenia appears to be, there are some plans to introduce retail competition, so competition on the distribution network side. And
yes.
Do you think
it started already? It has started.
And do you think that that could incentivize the growing care and investment in energy management systems on the distribution?
I am sure. A good example of that was many years ago when the Ministry of Energy of Armenia decided to open licensing, to provide licensing to private local companies in building small hydropower stations. They just announced that we can provide to private companies licenses for constructing small hydropower stations and operating them, connecting to the countrywide grid and selling their generated energy to the network. More than 300 small hydropower stations appeared in Armenia. More than 300. I do not know how many of them are operational now. Definitely much more less than they started with. This is one of the examples. Of course, there is a bad consequence of bad implementation of the project because these companies were abusing the rights which were given to them. They brought damage to many small mountainous rivers. And the second case was free license to small companies or individuals for building solar power stations of their own, and providing licenses also to companies who want to build solar stations not for own use but for commercial needs. And these possibilities, open possibilities, challenge the market and challenged too much investment into the energy sector. That's reality we are living in this society.
Okay, I think on that optimistic note, we'll conclude the presentation. Again, thank you a lot, Avetik, for joining us today. We will, as always, upload the presentation on YouTube and share the link with the NFL community. Yeah, so I think we will conclude here. Thank you everyone for joining, and thank you, Avetik, for presenting.
I thank you very much for invitation, and I thank you for listening and for your patience. Thank you very much.